Usually when they introduce an insurance guy, people decide it's an early exit to lunch, and it's not very interesting. But I'm going to try and convince you that this is a particularly interesting time in the insurance industry and more broadly financial services. So you can see by this slide, the global insurance industry is approaching $5 trillion in annual premium. That's our revenue or top line. For relevance, the US GDP in 2016 is about 19 trillion. So it's a big part of the economic fabric globally in the US. The pie on your right is US insurance, and it's about $250 billion in US auto insurance, which is private passenger auto. All of you that aren't exclusively Lyft and Uber customers buy private passenger auto insurance, and then a smaller sliver is fleet and commercial insurance. So given that I've been hanging episodically around the Stanford campus for many decades, we that watched the 2005 DARPA Grand Challenge saw Stanley highlight the beginnings of autonomous vehicles. This is my colleague's affiliate company, Waymo's van on its way probably to Ann Arbor to test out in the snow. So we know that autonomous vehicles are coming. They're going to be a massive change in the lives of our customers. And we're absolutely convinced, the insurance industry broadly, but our company in particular, that being on the side of safer lives, healthier lives, and reducing deaths in the country and globally is absolutely the right way to go. So here's the challenge. This is a recent piece from Bloomberg. I would argue that the executive leadership of most insurers fall in the bottom rows. So those are the 45-year-old and older folks like me that fall into the doubter category. The top rows obviously indicate that younger folks believe absolutely that autonomous vehicles are going to be here sooner rather than later. And what does that mean? So I'm gonna put one of my good friends on the spot. I'm gonna ask Joe Schneider to stand up and just wave at you guys, and then I'll tell you why I'm singling him out. Joe is the co-head of the Global Autonomous Vehicle Practice at KPMG, and Joe and several of his colleagues have taken the courageous position of trying to quantify the change on the insurance industry, and more importantly, try and estimate the timing of the impacts on the industry. Obviously, if my car doesn't bump into your car, you do not need to buy the product that I am currently manufacturing today. That has deep consequence to our business because I have 20,000 folks, our employees, agents, and their staff that make their living selling a product that may be irrelevant going forward. This is a decay curve in losses, and if you really want to get deep and into the weeds, Joe is your guy to talk to. The most important and consequential signal out of this chart is that losses and loss frequency in our world, that is the number of accidents, are going to decline perhaps by as great as 90%. So that's the provocative challenge for the executive leadership of all global insurers, is how do you reinvent yourself and create relevant products and services that take care of customers, knowing that in our case, we have a $9 billion top line. About half of that is going to decay towards zero. And this is another element in Joe's team's study, but we could go from 192 billion in losses down to maybe 55 billion. The good side of that is people aren't getting hurt, they're safe, they're enjoying the experience of being in an autonomous or semi-autonomous vehicle, but I cannot charge you for a product that isn't helpful. So that's the setup. So as Steve mentioned, there's been tremendous interest in disrupting insurance. This is CB Insight's chart of InsurTech venture activity. These are both corporate and other venture capitalists investing. You can see the orange line is deal count and the dollars put into this business from venture capitalists. Small teams can truly use open source software, cloud-based computing, and ubiquitous mobility devices to disrupt large incumbents that are saddled with legacy systems and slow-moving regulated processes. Last comment from opening thoughts is we started a corporate venture capital team in November of 2010. We've completed 89 transactions in 48 companies, all aimed at disrupting ourselves. And it's quite an experience to go into your fellow colleagues and explain to them you're investing in self-reinvention.
Great. Thank you. Thank you very much, Peter. Our next speaker is Peter Norvig. Peter is Research Director at Google. And of course, we all know Google so well that I think we often take it for granted. But of course, Google is a whole lot more than a search engine company. And Google has both the strengths and challenges of often driving the leading edge of technical change. Peter.
Okay. So I guess you did a great introduction and said that there are these opportunities here, that there'll be new applications, entire new business models, and that's exciting for each of you in your own industries. I think of myself as a tool maker and tool user, and so the level that I'm interested at is saying, how does this change the way we do the whole software development and product development process? And I think there is a fundamental change in that we've had 50 years or so of trying to program computers and getting better at it over time by developing a tool chain. But mostly what we taught our programmers was to say that we want to make programming a mathematical science. We want to, in the limit, prove our programs correct. Now, of course, we know we only really do that for the 10-line toy programs. We never prove the real programs correct. But that's kind of the mindset we use, that if we really wanted to, we could do that. And we make our programs better by writing assertions. And the assertions are things like assert true or assert equals, and then we test it, and if they all work, then you ship the software. Now we're saying we're going to look at the whole thing differently, and we're no longer going to have this certainty of true and false, and rather we're making software more like empirical science, like a natural science, one that's going to be driven not by proof, but by experimentation. We have some data, we run some experiments, we get some results. There isn't necessarily a correct result, right? So when Google shows you a search result page, there's no right answer of what's the #1 result. It's, is this seem like a good answer or not? And we have various ways of asking people and rating the quality, and so we get a number for the quality, but it's not right or wrong. It's experiment with nature for which we see the result. So now we have to train all our programming staff to think in this new way. In some sense, throw away everything they were trained for and say, you're now a natural scientist, you're doing experiments, the data is going to be very important. We always thought of the data as being secondary, and our tool chain was trying to make it harder for a programmer to insert an error into a line of code. And we have some good things to do that, right? So it's much harder now to pass the wrong type to a function because the compiler will complain. But now if most of the emphasis has switched from the code that you write to the data that you use, and that's where your currency and your value is, we don't have 50 years of experience of handling data. We have very poor tool sets for handling data. And one of my hobbies is reading the headlines when a major company has some sort of outage and service is down or whatever. and try to get to the root cause of why that happens. And most of the time, it's not because some programmer wrote the wrong line of code. It's because, well, this data file with the DNS entry got confused, and then there was a cascade of problems, and then something went wrong. Because we don't have the culture of saying we're going to pay attention to the data. We don't have the tools to check the data to make sure that it's right. And we're going to have to invent that as we go along. Then we're also going to have better tools for understanding and communicating what it is that we built, right? So we built a model, we do the experiment, it gets 90% correct. We pop the champagne and go from there. We'd really like to have better understanding. Say, yes, it's correct most of the time, but when is it going to be wrong? What does it know, and what does it not know? Can I have a conversation with my model in terms other than saying, here's a new example of you got that one wrong, I'll show you some more. And we're not very good at that right now, right? So I'd like to be able to say, you know, I asked you to identify cats, and I showed you a million pictures, and you got most of them right, but you got this one wrong. If I want to fix that, right now, my best recourse is to show you another million pictures of cats and retrain the model, and then it will probably get better. But what I really want to do is have a conversation of saying, oh, you got that one wrong. You know, maybe you should pay attention to the shape of the ear here. That's probably the key in distinguishing this particular picture. But we can't really have those kinds of conversations with our models yet. So we're going to have to make them have two-way conversations about the contents of the model rather than just about the data that we feed in and out. And then finally, if we are shifting so much of our emphasis from the code that we write to the data that we use, we have to take that data more seriously. And we have to preserve the privacy. We have to have a contract with our users and saying, this is what we're doing, make clear what we're doing for them, make clear what the terms are, where their data goes, and make sure that we're good stewards of it because it's going to be vital to our organizations. And if we want to collect more of the data, we have to earn the trust that we're taking care of it. Thanks.
Great, thank you very much, Peter. Our next speaker is Luca Marighetti, who's Managing Director at Swiss Re. Swiss Re is one of the two largest reinsurance companies in the world, and Luca is involved in driving culture change in a large organization. Luca.
Can I maybe have? Yeah, of course. So what I would like to cover really is a few things that may be insightful for those who are facing a similar problem, which is we've been experimenting with tech. Some people call it digital. We prefer to call it tech. Digital is part of tech for a couple of years. And it has been a great experience of exploring, experimenting, and so on. We're not the only one who have done it. Basically, everybody in the industry has done it. But then if you ask the question, what is the impact? Then the impact is very thin. And we're asking ourselves why, okay? So, and if you want, there were two parties. One party saying, okay, that's a new economy all over. You know, the bubble is going to prick, and then we have the next year of peace. And the other party say, no, that's different. It's not that tech is not real. It's that we're not properly understanding how to deal with it. And the impact is going to be profound. So we came to that second conclusion. And then we tried to have a rational discussion about it, and we discovered that everybody has a different representation of what tech is all about. So we spent quite some time clarifying what it is, and we came up with those four categories that you see on the slide. The first one being, you know, digitization, indeed, which is the ability to convert objects into digital representations. So you say, okay, nothing new. Well, it's pretty new because, you know, until 10, 15 years ago, that was not a widespread capability. Now everybody can do it. Second, computational power. You can, if you want, manipulate those digital representations in ways that were unthinkable just a few years ago. That changes a number of things. I'm going to come back to that. Thirdly, you can do that everywhere. And if you don't have enough computational power on your smartphone, then you use, for instance, the Google Cloud. And that multiplies, if you want, the capability that you have. And finally, you have real-time access to knowledge. And for those of you who are at least my age, think back at a time when you were using the Britannica and how cumbersome it was to extract a little bit of information from a paper-based encyclopedia versus what it is that you can do today. In just a click away, you basically get all the information you want. So the combination of those four things, we think, is systemic and is changing the entire economy, and that's what some people refer to the new machine age, other people talk about Industry 4.0, but that is changing many things. For insurance, it changes really things alongside two axes. One axis is the way we manufacture the insurance product. The insurance industry is a very inefficient piece or place. Insurance, I think, is far too expensive, but part of it is driven by regulation, part of it is driven by Stone Age processes. Part of it is also driven by constraints in what technology can do. One thing we're initiating now with Stanford is a project. The problem of automatic content ingestion is not solved. I cannot give a machine a PDF and expect a machine to be able to translate or transpose that into processable bits. So the best AI algorithm doesn't help me 1 inch if I'm not able to, if I need a mechanical Turks to type in the data, then I'm basically dealing with lemons. So that problem is not solved yet, or at least not for our industry. So from there, we said, okay, so we need to clarify what it is, and we need to clarify what it is good for. One axis is we can use technology to improve, to become more efficient, to increase productivity. And insurance is the perfect target for the automation of knowledge work if we solve some of the technical problems. Then there's another dimension, and he has been talking about that earlier, which is technology changes the nature of risk. So you have some risk pools that are doomed to shrink in pretty dramatic ways. So motor is one example. But there are others that are ballooning in unexpected ways, and we don't really know yet how to insure them. And cyber is probably the best example for that. And with cyber, I don't mean just malevolent attacks, so meaning the Chinese wanted to hack Steve's PC. They probably don't care too much, well, maybe yes. But what I mean is with this transposition of so much content and steering mechanism and decision making away from humans to machines at a huge scale, we have become dependent on legacy systems. Some of the legacy systems are old, sometimes 40 years old. Many of them are in a state of terminal decay, and the people able to fix them are literally dying away. It's a demographic problem. Think back 1 year and a few months ago, there was the grounding of Delta Airlines for 3 days. It was a small glitch in a satellite system of a legacy system. So those are risks that are existing and today not really covered or indirectly covered, but that is going to change because it's not like the balance sheet of the insurance industry. They may be vast, but they're not unlimited. Okay, so having said that, we said, okay, so this is commonsensical, this is sober. How do we do in dealing with tech? And that's the next slide. And then we said, okay, maybe a way to crack it, and we believe that's probably the right way, is to look at two axes. One axis, if you want, are the different technologies, and the other axis is the value chain of insurance, of our industry. And if you break down it that way, then you discover that for each particular piece of technology, in a particular link of the value chain, you are able to define very specific applications of what it is good for. We call that use cases. It's much more difficult to do than it looks in paper, But what we're really doing is we're breaking down technology and value chain bit by bit. We're defining use cases, and then we use those use cases, asking the question, is it worth digitizing? Is it worth putting on a computer, and so on, and then do it across, if you want, the entire value chain. And we find that with this process, we become much more precise, and it's much easier to find the right applications. So that is my message.
Thank you very much. Let's start with what I think is the big, hard question that several of our speakers have alluded to. How do you get tangible benefit from data science and machine learning and AI technology in your organizations? Several of you have referred to cases where the promise exceeded the reality, and it was hard to actually get some use out despite directing resources in a given direction. Others of you alluded to examples where real-time access to data and advanced analytical tools can produce measurable and tangible outcomes. What are the differences? How do you manage that? You're all senior executives that get paid for getting it right and fired for getting it wrong, so there's a lot at stake here. You have the ability to make or harm your companies. Who would like to take a stab at that first? Peter? Peter Gunder?
Okay. So there's a whole bunch of people in the audience that know the ground truth at American Family. So I may be bordering closer to getting fired here as a senior exec, but we explicitly set up an experimentation group that was physically located miles away from our headquarters. It was launched formally in 2014, completely in the cloud with fresh tech. And in addition, we, as I mentioned earlier, launched the Corporate Venture Capital Group. You know, there's a real question in my mind as to whether legacy companies can retrofit themselves fast enough to win. And it is distinctly possible that if one has an equity stake in a fast-moving predator, you may have a better portfolio of options. So we've got stories of incremental improvement at our core business, but there is a deconstruction and a reconstruction process that needs to happen at these legacy companies, ours being one. And I don't think anybody that has a company that's over 50 years old has figured it out fully.
Peter, how do companies balance?
Wait a second. Can I be the contrarian?
Yes, please.
Sure, how do you know I wasn't about to be the contrarian myself? But go ahead,
I'm more
Luca.
contrarian than you.
Okay.
So we are taking the diametrically opposite approach, okay? And because we find, you know, the tech is not a beast outside the building that needs to be contained. I think tech is something that needs to be embraced. And then again, thinking back at why it is that we see so little impact, because everybody's playing with accelerator, garages, and different names. And I think that there's a almost perverse logic to it. Typically, what I find, and not only, I mean, the insurance is not the only industry I've been working in, but I find in every industry you have the same thing happening. You have two groups. You have conservatives, so the Republicans, and you have the Democrats. Okay. So the Democrats, they want to change everything, and the Republicans, they want to keep everything as it is. I mean, not the current one, but it used to be that way. And what happens is that you have a healthy balance between innovation forces and conservative forces. Now, what tech is doing is basically increasing the urgency for changing things. And so on, the organizations are not prepared. If you take away tech from the responsibility of the organization, the following thing seems to be happening to me. The conservative forces, they say, great, I officially can avoid dealing with it. Okay? They do that somewhere in the garage. Unpractical things will emerge because the garage is an ivory tower. And then, you know, when it shows up, I find a way to kill it. And by the way, the next round of cost cutting we know how expensive it is. The innovators, they are really disappointed because they get stripped of the little resources they have to innovate, and it's all given to those other people sitting in the garage. So whatever comes out of the garage is not invented here. And so you end up with an unholy alliance of conservatives, and it's basically a bipartisan agreement that whatever the garage does is bad, and in the meantime, nothing really happens.
So, go ahead. I feel compelled to respond to the government metaphor. So let me give you a couple of examples where the garage has had a profound impact on our core business. We know Steve Blank because he's a well-known name, but lean startup isn't necessarily a practice that is profoundly practiced in all businesses. We launched a lean startup capability. We experimented in the garage. We have a corporate vice president in charge of lean startup, and all tech projects go through a lean startup framework with ethnography, design thinking, human-centered testing. So there are pathways from the satellite to the larger mass body.
So I guess I'm with Luca, and I remember when I took over research at Google about 11 years ago, Eric Schmidt told me, at Sun Microsystems, he felt like he had some of the smartest people in the company in the Sun Labs and some of the lowest return on investment. So he told me, don't do that. And so the way we set things up is to try to not be separate, but to try to be completely integrated. To say that we're not going to build prototypes in research and then do technology transfer. Rather, research is going to build things. And if they need more help, they'll add engineers onto the team and we'll have a partnership. And that's true in two areas. It's for inventing new products, so all the things we've done with speech recognition and translation and computer vision and so on sort of came first from research, and then the product team said, yeah, that's good, let's run with that. And then is also improving existing products where we could say, well, we like people to click on ads and make us some money. So what if we did some data analysis and made 10% more? Would that be good? Yes, let's do more of that. Or can we make the energy usage in the data center 10% more efficient? That would be good too. Let's do that as well. But it's always integrated, and I think one of the choices we've made as a company is to essentially have one system, one software code base that's shared from everybody, and I think that's made it easier for us to start small and then integrate into the rest of the company. There's also overhead in making that choice because now more people have to agree. Other companies have made the choice of saying each team gets to have their own environment that doesn't interact. It turned out it's worked well for us to do it our way.
We need some Solomonic contributions.
Are we all satisfied with this? Okay, we're going to move on then. Yeah, next question. We beat that one to death. Okay, very good. Peter Norvig, I want to come back to something that you said. You talked about the evolution of programming as a skill and how we need to pay more attention to data. It even sounded like you were saying that we need to make sure that our computer scientists also have a background in the social sciences and liberal arts, although you didn't quite say that. You might want to come back to that. You even intriguingly talked about conversations with a machine learning algorithm, and I'm pretty interested to know what it might look like to have a conversation with an algorithm. So I was hoping we could ask you to go back to this idea of what it means for the trade and skill and art of programming to be evolving, and maybe relate that to Google as an employer. Is this about culture change? Is this about training your current programmers. I don't know, does this mean you can go hire Greek literature majors and teach them programming rather than hiring programmers and teach them how to understand humans?
Yeah. So we're still a pretty computer science-centric company, and we tend to hire computer scientists even for things like product marketing roles, because we think it's easier to teach a computer scientist that part than the other way around. So that's probably going to continue into the future. But we do think about this training at multiple levels, right? So we're lucky enough to be able to hire many of the world's leading expert PhD machine learning people. Some of them come from Stanford, so thank you for that. And they can manage for themselves. So that's great, and we want to help them achieve more, and we have tools to try to do that. Then the next level is a software engineer, is a professional software engineer, but doesn't have any of this experience or background, and how do we train them? So we have an internal training class, and many thousands have gone through that. I think about a third of all our engineers have taken this internal class, either in the classroom or online on their own, and have tried to get their skills up to date that way. Then the third level that you were talking about, I think we're just starting to try to get to, of what if you're not a professional programmer, but you have some data, you have some questions, you want to be able to ask that. I guess the closest we've gotten to that is we've gotten it down to the level of the statistician, who's kind of the amateur programmer. So we can't quite hire the literature major yet, but we can hire the statistician who, maybe they're used to writing 100-line R programs rather than 100,000-line Java programs, and we try to make the tools to make them be effective with what they have.
Peter Gunder, Luca, do either of you want to comment on that? All right, so let me ask everyone in the audience to start thinking about what questions you'd like to ask our panelists, and while you're thinking about that, let me ask one more question, and then we'll turn to the audience. I'm wondering what corporate best practices are for disseminating data and machine learning and analytical tools in corporations, and how you handle the fact that, for example, at Google, an individual's search history is so sensitive that, in fact, very few Google employees get access to it. Or at an insurance company, you've got all this incredibly private data about someone's medical history and past behavior and so on. And if you make granular data as opposed to just aggregate data available to your employees, there's the potential for them to do great things with that, but it also carries risk and compromise. So who'd like to comment on how do you make powerful data sets and tools available throughout an organization, and how do you balance that against protection?
Maybe I make a start. This is indeed also, especially in view of the upcoming regulation, a challenge, because we need to be able to control who has access to which data, for which purpose, from which jurisdiction. That is a problem that is not really solved, but will become urgent as a problem. And we're talking in 6 months, not in 6 years. So that notwithstanding, data have always been central to insurance. That's how we calculate risk, how we assess risk, how we make our pricing, and so on and so forth. So if that data goes away, then the world becomes in the extreme uninsurable. As far as we are concerned, we are a bit far removed. Yes, we also have access and we have private data in our data sets. But at the end of the day, 85% of our business is insuring insurance companies. So basically, we are taking a portfolio view and see how much of the excess risk our clients are willing to cede, we're willing to take over. So we're an expanded balance sheet in a sense, to say it in very simple terms. For that, we have indeed a group of data scientists that do nothing else but go through data sets, portfolios, and so on, and try to make sense out of it. And that's the way we solve the problem. In addition to that, we also rely here and there with data firms partner with whom we run projects, analysis, and the like.
Does anyone else want to comment?
Yes, I think you characterized things well, that we put a lot of controls on our data. We understand that sometimes the engineers have to have access to it to improve what we do. But we want to make sure they do that at the appropriate level, sort of at a need-to-know level, right? So when I was running the search team, I had very limited access to search data, right? So I could say, show me a set of random queries, and it would do that. But I couldn't say, show me the geographical location precisely. I could only get sort of aggregate city or country level data. And I couldn't say, show me a session that's a day long, all the queries somebody made in a day. I could say, show me 3 consecutive queries. And I'm not going to show any more than that, because then you might be able to reverse engineer it. So we had, sort of dozens of different types of ways of limiting access or aggregating so that I could see properties of the search stream as a whole, but couldn't de-identify people. And we spent a lot of time trying to figure out what's safe to be able to show and what's not. So the access is part of it on a need-to-know basis, with increasing security as you go and increasing training before you get to that next level, right? So I could have gone back and say, I need to see this more, and then I need a proposal for why I need to see it, and then I'd have to take a training class to make sure I wasn't going to screw it up, and then you could get to the next level. So training and access, and then of course encryption all the way. All the data is encrypted at rest and in transit, and we do a lot of security reviews to make sure that it's doing what we think it is. We hire teams to try to break in and break our security, and so taking it seriously and making that part of the standard practices.
Good, thank you. Peter Gunder, did you want to comment?
Yeah, I think obviously the essence of our business is trust, and as has been mentioned, we're a digital business. Given our scale, answering the question, what are best practices, has come to us through the form of many partnerships. So there are folks in this room, the Accenture folks, the Microsoft folks who we have partnered with, as well as many others, to seek to get best practice. But it's absolutely critical that we not try and go it alone when the asymmetric battles are being fought.
Yes, and they are asymmetric. Any questions for our panelists? Yes, let's start there. And then you. You first, and then there. Please use one of the microphones.
For sure, so I see that the
Please use one of the microphones. Thanks.
So I see that the blockchain is another buzzword. So could you please elaborate on the blockchain context within the insurance value chain?
You go ahead.
Sure. So Dan Bonet, if you're in here, you got to raise your hand because I made some.
He will be here at the end of the
Okay,
day.
good.
He's
So
giving
I
a
can
talk
say-
at the end of the day.
Look, the distributed ledger concepts are provocative. They've been explored and examined in banking, and insurance is increasingly evidencing consortia of multiple parties that are coming together to explore how blockchain can be applied to basically deconstruct the value chain. I would argue strongly that blockchain experimentation should not be done inside the core business because it is so profoundly disruptive. So we do have some experiments going on. We do believe it may take apart our business, but we have not asked the core business partners to disaggregate the going concern and build blockchain into tomorrow's business model.
Good. Thank you. Next question.
Hector Garcia Molina from Stanford.
And the founding executive director of the Stanford Data Science Initiative.
I know
Thank you for being here today, Hector.
I know a lot of you. Thank you. So I noticed in the first question about how do you handle disruption that there was some disagreement on the panelists. So I wanted to drill a little deeper on that one.
Good.
And I'm wondering if the let me call it the employee profile difference might be one of the factors that decides, because I suspect that at a legacy company like an insurance company, you have a different type of regular employees than at a high-tech company like Google. And I mean that the Google employees, in general, I suspect, but I want you to tell me if they're more used to disruption from an early age, so they can handle that process. And at a legacy company, there's a lot more people that have a hard time with that. So maybe that drives which model is better for handling disruptive technologies.
Yeah, so I can give you some practical evidence of what we did. In December of 2012, we spent $239 million to buy a mobile-first insurance company called The General, a funny guy with a hat that looks like me, a little shorter. The intention there was to buy a business that was completely distinct, that was national in scope, that had a different operating model and had a different tech stack and different folks. The following year, we closed on a $660 million transaction to buy 1,000 people, if you will. You know, one doesn't, the reference to indentured servitude isn't appropriate, but to get a capability. So that is a Boston headquartered business. It was private equity funded. It's a 10-year-old, 12-year-old business. And it was our intention to acquire businesses that had different cultures that could educate our culture and to slowly help us understand that the likely successor businesses are going to be the agile, tech-savvy businesses.
Peter, I just wanted to check your math. 660 million for 1,000 people, right?
Yep.
So each person was worth less than $1 million?
We are savvy investors.
It does sound like a bargain.
Indeed. And the drivers of growth and profitability from that transaction have been very substantial on our business.
All right, so you're skilled in finding value that others don't see. We get that.
Perhaps.
All right.
Yeah. So Hector, I think part of the issue is the way your product cycles work influences how you set things up, right? So I had research integrated with the rest of the team. If I was running a computer game company, I probably wouldn't do that. Because if I did, what would happen is I'd say, you know, here's a researcher, we're going to embed him in the team, he's going to invent something new with virtual reality or whatever. And then I know what's going to happen is they're going to say, we really got to get this game out before Christmas, and we're a little bit late. So could you just for a couple of weeks, drop what you're doing on the research and pitch in on here? And then after a couple of weeks, it becomes a couple more weeks and a couple more weeks and a couple more weeks, and pretty soon he's working full-time on development right up to Christmas rather than working on research. So Google has a luxury that we don't have dates, big deadlines when we say everybody's got to hustle to hit this deadline. Rather, we say, you know, every day we're launching an update. We don't have to put a CD into a box, we push code to a server, and since that happens continuously, it's easier for us to be running at multiple timescales. To say, you know, some people are working on this week's code, some other people are working on next month, and some other people are working on next year, and that all can fit together because we're pushing continuously.
Maybe to bridge the gap a little bit, because I think there's a difference between running a retail insurance company and running a reinsurance company. And if you're running, and I've been working in retail insurance before, so I know it a little bit, a lot of the disruption that is occurring is actually in the distribution side of the business. And that's where the impact and the disruption of digital is actually obvious for everybody. You know, we have all learned to buy stuff at Amazon. I Again, that is something that we've learned in the last 10, 15 years. It didn't exist before. So now also insurance is being sold through those type of channels, and that creates a lot of strain and a lot of conflicts between distribution channels. So, and the resistance in the organization is much bigger than it is in reinsurance. In reinsurance, tech is welcome because it allows us, among other things, to do much better work with data than we were able to do before. So meaning we want the expert actuary being able to use tech to become a better actuary than he was before, as opposed to replace him with a geek who may understand a lot of tech, but nothing about reserving. So, and I think that's where the differences are, and that's why for me it's so important that you look at the value chain and you look at the use case, because then you can make the right decision in terms of how to make it happen in terms that are practical.
Very good. Thank you. I'd like to turn next to Tom for a question.
Yeah, this question is for Luca. How is climate change and the risks associated with that, such as increased frequency and severity of extreme weather events, how is that affecting the insurance and the reinsurance industry? And what role can the reinsurance industry play in convincing those political leaders who believe in markets but are not yet convinced by the evidence that there are real market signals of the impact of climate change?
Climate change, the impact of it, I can quantify. For us, it was 3.6 billion. It was in the press, I think, yesterday or this morning. So very expensive. So how much of it does trace back to climate change? Probably a lot, but we don't know for sure in terms of being able to quantify it. However, as climate change evolves and we learn more about the impact, our models are evolving, but the reality is that there's a large portion of the world population that is living near shores. And living near shores is in a world of climbing ocean level not a very good idea, because the danger of floods is simply higher. So, and those things we're now factoring in. We're also working very closely with governments to address those issues, and we take it from there.
Anyone else want to comment on that? Other questions? Yes, there, and then there.
So, disruption, what it means to an insurance company versus what it might mean to Google, could be an interesting conversation. So I was just looking at the slide that's up on the screen from you, Luca, and you talk about contextual computing. Every day I use my Android phone, it has Now on Tap. It has a very good sense of my context and actually delivers into that context. I don't have to look for information, it comes to me. It seems to me that many of your use cases actually match technologies that Google already has. So when you look at this delivery of IT in the cloud and Google's rise as a cloud platform company, is there an intersection where what is disruptive to you needs a narrower definition on your side, and it needs a broader definition on Google's side for the disruption to be realized?
Before Luca responds, I just want to observe, you are the only person I have ever heard claim that they think their interaction with their phone is contextual. In my experience, everybody complains it isn't, so we do have one satisfied customer. Yeah.
Shall I start? You want to start? Go ahead. So no, I think we see that technology and business are converging in a way that we are starting to learn what to do out of it. So, and insurance, and that's what I was referring earlier when I was saying technology is changing the nature of risk pools. Some risk pools are shrinking, or may become larger. In that particular case, one of the things that we're thinking about was, take accident insurance. So you're going to do some, not even extreme sport, you go skiing. So skiing is a dangerous sport. So if you want to have accident insurance, in many cases, you need to buy insurance for a year. But you need it only potentially for 3 days. So if your device knows that you are going to ski, where you're going, the weather's going to be good, so you're going to be skiing. It can offer you coverage for 1 day for, I don't know, $4.99 in a moment where you're prepared to buy it because you know you need it. And also in a fashion similar to what has happened in the music industry, it offers you the single song you want as opposed to selling you the album. And that is, I think, something that we will see increasingly emerge, partly already exist, where the insurance packages get atomized to a large extent, and where people will start insuring for things they didn't buy insurance for in the past, whilst at the same time, other risk pools may be shrinking.
I just want to take the concept of industry boundaries blurring and expand it. Candidly, insurance is a reactive reimbursement. It's a negative consumer experience. Our discussions with our customers don't result in people standing up going, I really had a great claim experience. What they say is, I'm really saddened and angry that the pipes broke in my basement because my heating system failed. Thus, there are opportunities for insurers to reinvent themselves from reactive reimbursers to proactive protectors. We partnered with Microsoft in 2014, for example, in Redmond, to do a home automation accelerator program, and we are actively investing in loss mitigation consumer technology offerings because customers don't want a basement full of water. I don't want to replace expensive hardwood floors. I'd rather have a customer pay for a valuable service that prevents losses. And that's a concept that we're spending a lot of time thinking about.
So I think at Google there have been a bunch of disruptions. I think as primarily a software company more than a hardware company, we're more able to deal with that. But some of them come as surprises and some of them are evolutions, right? And so there are these moments. I think 9/11 was a big moment for us, which was the first time we said, we thought we were building something that's kind of like a library that has a collection of information in it. And this was the first event where people were turning to the web in real time for their news rather than turning to television or radio. And so now we said, it's not good enough for us to have yesterday's website. We need the website from this hour or this minute. And that revolutionized the way we thought of things. I think Katrina was another event for us where we said we thought Google Maps was like an atlas. And now we said, well, today's picture is different than yesterday's picture. We're going to have to deal with that. A couple of years ago, Sundar started saying we're a mobile-first company. And there wasn't one event. There was, you look at the charts of usage, and it seems like they're going to cross pretty soon. And now they've crossed, and most of our customers are coming from mobile rather than from desktop. And so we had to deal with that. Now Sundar's saying we're an AI-first company, and it's not clear exactly what having the slogan means, but it does mean that lots more people are paying attention internally. And we are trying to get those contextual moments to you, and we know we got a long way to go. I just yesterday captured a screenshot of the suggestion that said, it's time for you to leave to your appointment to service your Toyota. And it got that right, and it got the right time to leave, and it got the map with a little pin and so on. And then it said, time of travel, 20 minutes by bicycle. Right? So it's almost there, but didn't quite have all the context. So we still got work to do.
I had promised one more question, but I see that we're out of time. Is that okay, Sean? Or did you want to take the last question?
I wouldn't mind, but
Please, go ahead. One last quick question.
So you're talking about the new computing paradigm that we're entering, how everything has been rules-based up until now, and now it's about outputs that change, it's adaptive, they're more dynamic. And I'm just thinking in terms of how this forces us to redefine risk for an organization, particularly very large organizations. So mitigating risk has always been about writing those rules. It's about locking things in place, not deviating from things that we already know, trying to predict what those are, defining value chains by understanding what leads to what very specifically, very deterministically. But as we enter this new computing paradigm where our outputs change, our computing becomes soft and it's more experimental, how does an organization, particularly a large one like yours, define risk? Because it's now more risky to lock in rules, I would say. It's riskier to throw 1,000 engineers at something and build a system that doesn't break, because that's not innovation. And innovation is about breaking, it's about changing, it's about adapting. So how does an organization that has to mitigate risk deal with this new definition of risk? If that makes sense.
Anyone? Hard problem.
So I guess one thing I could say, I talked about this change from a logical approach to a more experimental approach. And another change we have is going from a kind of the micromanager approach of saying a programmer's job is to say exactly what steps to take one by one, as you were describing. We seem to be moving away from that and rather saying that what we have to do is provide the computer with a goal function or an objective function to maximize. And in machine learning and in economics and all these related fields that do optimization, there's an issue that they always start from, you tell me what I'm trying to optimize, and now we have all these cool techniques for doing that. And I think what we're running up against now is saying, we don't know what to optimize. Right? So yeah, optimizing profit, that's probably a good thing. And there's some things where we know, and energy efficiency, the more you save, the better. But others, we don't know what our customers really want. They don't know what they really want. We're trying to optimize that, but we're in the dark as to what exactly is the right thing. And so I think we need better tools. It's not so much risk, but just trying to figure out what are the risks we're trying to avoid, what are the good points we're trying to head for, and what are the potential bad points, and how much do they count. We're going to have to understand our users better to know what to aim for before we can put a program in place to optimize that.
Right. Makes sense.
But I would say I find that with technology and the availability of data, actually we are better able to mitigate risk. In fact, entire industry is moving from, the job was understanding and covering risk, and now increasingly it is predicting and preventing. It's also, it used to be backward looking, and now we can do stuff that is forward looking. It doesn't impact it, the motor business yet, but I can see the moment the interconnected cars start generating the data they seems to be generating, then you can take a probabilistic approach to insurance as opposed to the standard approach. And that we've seen, actually, Swiss Re had been pioneering that for natural catastrophes in modeling things that may happen in future, of which we don't know whether they've happened in the past or not, but for which there's a certain probability that they may occur. So in that respect, I see things improving as opposed to destabilizing.
Good. Well, thank you very much. Please join me in thanking all of our panelists.